In this video, we are going to try to solve problems involving two equations of lines, trying to find the intersection of those lines, which is called the solution. Sometimes this is called a system of equations problem. So systems of equations just means where do two lines intersect, where do two lines cross each other on the coordinate plane, and what coordinate is that at? So two straight lines can only cross at a single point. There we have a blue line, there we have a red line, and we can see that they only cross at one point. That is what we call the solution to that system of equations, the solution to those two lines. We can see that that's at the coordinate x equals 2, y equals 2. That is the solution to this system of equations. It's not too complicated when we're given a graph, but if we're only given the equations for those two lines, it can be quite a bit more challenging. In this next slide, I'm going to go through the algebra method of that, which is a little bit difficult, to be perfectly honest. But I want to review that. And then after that, I will talk about a guess and check method for finding that solution, which may be a better option for you. So using the algebra method, if both equations are in y equals mx plus b form, for example, y equals 2x minus 6 and y equals minus 3x minus 1. What can we do? Well, since these are both equal to y, we can set them equal to each other. Hopefully that makes sense. If they're both the same as y, they must be the same as each other. So we can say that 2x minus 6 equals minus 3x minus 1. And you may be aware that when we have an equation and there's only one variable in it, we should be able to solve for that variable. So that's what we're going to do next. We are going to try to simplify that and solve for x. The first step I'm going to take is to add 3x to both sides. That's going to cancel out, let me add some, that's going to cancel out this term. But we need to add 3x to the left side. That gives us 5x minus 6 on the left is equal to just minus 1 on the right. Now, since we're trying to isolate x, we want to do the opposite of subtract negative 6. So we're going to add 6 to both sides. That's going to cancel out our 6. And when we do that, we are left with 5x equals 5. One last step, we're going to divide both sides by 5, and that will give us x equals 1. So we've done a fair amount of work here, and what we've learned is that the x part of our coordinate must be 1. It's going to be 1 comma something. Now we need to find out y. We can use this value of x and one of the equations. I'm going to use this equation right here to figure out what y must be. So all we have to do is substitute in that value of x into this equation. We just grabbed this one up here. We dropped it down and said, let's use this and let's make x equals 1. That's going to tell us what y must be. Y must be 2 times 1 minus 6. Y must be negative 4. We are done. We can put together our coordinate. The answer is 1, negative 4. Now, I realize that may feel like a lot to do for a single problem, and you are not wrong. That's a little bit challenging. So I want to give you an alternative, and that's with the guess and check method. So here we have a similar problem. What is the solution to these two equations? Y equals negative 3x plus 4, and y equals 3x minus 2. but we are given these 4 answers. One of them must be the correct one. So what we can do is we can first check these equations for x equals 2, y equals 1. Does this point make both of these true? If it makes both of them true, then we found our answer. So let's start out with this one. 1 is equal to -3 times 2 plus 4. We're trying to figure out, is this true? Simplify. 1 is equal to -6 plus 4, which is going to be 1 equals 2. That is not true. So we are going to rule out option A. I'm going to clear out my drawings here so that we can continue on. We have ruled that one out. Our next one is x equals -1, y equals 2. And I'm going to, once again, I'm going to substitute into this one first. 2 is equal to -3 times -1 plus 4. Now, I would encourage you to use your calculator for this right side to make sure that you don't make a math mistake here. And when you do that, you should get 2 equals 7. Also incorrect. So we move along. I'm going to erase that so that that's not distracting us. We are down to C. X equals 0, y equals 3, and we substitute that in. 3 is equal to -3 times 0 plus 4. Sorry, that's a little sloppy. That leaves us with 3 equals 4. That's not true. We are down to D. We should check D just to make sure we didn't make a mistake up above, but we are checking x equals 1, y equals 1. 1 is equal to -3 times 1 plus 4. Sure enough, that gives us 1 equals 1. But keep in mind, we need to check that on the other equation. So we check that over here, and we plug in 1 equals 3 times 1 minus 2, and that also equals 1 equals 1. So we have found that this point satisfies both of these equations. That must be the answer. I know that that too feels like quite a bit of work, especially when you need to go all the way to D. And that's true. But let's do it one more time. You should recognize that this is the kind of problem that could take you a while and might take a little bit of extra care to make sure you get the right answer. Now, notice that these equations are not in y equals mx plus b form, but they're still linear equations. So we're going to do the same thing. 3 times x minus y, which is 1, is equal to 7. We put the left side in the calculator here, and we get 2 equals 7. That's not true. There's no need to check the second equation. So I'm going to erase that, and we are going to move on to our next option, which is x equals 2, y equals -1. And we get 3 times -1 minus, oh, I made a mistake there, 3 times 2, x is 2. If you caught that, excellent, equals 7. So this gives us 7 equals 7. 3 times 2 is 6. Subtracting a -1 becomes addition. That left side becomes 7, and that is true. But we also need to check this second equation now to make sure that it works for that. 2 times 2 plus a -1 equals 3. And sure enough, this left-hand side is also 3. 3 equals 3. And this time we only had to go to option B. So a couple of takeaways from this, I would strongly suggest using the guess and check approach. I think it's simpler and a little bit quicker. Be very careful about your substitution, but also be aware that this is the kind of problem that might take you a while. So now it's time for some practice on your own.